what I want to do today is I'm just going to go through De Morgan's laws. Okay, so we know that this whole thing that we're doing here is Boolean algebra. George Boole, the guy who invented it. But these, and you might think, well, this was written for computers, but it wasn't. In fact, Boole developed the whole Boolean algebra sort of in the early 1800s, long before computers were around. They came up with the whole idea of two-variable algebra, just with true and false. And De Morgan was also a British mathematician from around the same time. And he came up with these laws. Let me just share my screen here. Okay, can you see my screen?
Yes, sir.
Yes.
Okay, perfect. Okay, so the whole idea behind obviously doing Boolean algebra is we would want to come up with some sort of Boolean equation for a problem, and then we would want to design an electrical circuit to build that. For example, I don't know, let's say a burglar alarm. We could have a whole lot of switches on doors and windows, and we could have a panic button, and then you can come up with all the logic. You know, if the panic button is pushed, then output for the siren, or if a window is open and the time is less than 5 o'clock in the afternoon, then assume that it's not locked up, so don't ring the siren. So you can come up with a whole set of criterion for a system, and then you would build your system using electronic circuits and using AND gates and OR gates and NOT gates. You can actually build up an entire electrical circuit to do the job you wanted to do. So the whole idea behind De Morgan's law is it helps you to simplify. So you do this kind of thing in mathematics as well, where you simplify equations. So De Morgan's law helps you to simplify Boolean equations. So there are two of them. Okay, so so just excuse my writing here at the outset. I'm writing with a mouse, which is probably not the easiest thing to do. But these are actually De Morgan's laws. So he's got here A or B. Okay, now you're going to see the way that I write not. Okay, so in the book, we know that they write not with a little single apostrophe. Now, I've looked up to see why they do that, and I can't see it. So as far as I can see in the SAGs, that's the document that specifies what you have to learn for matric or for 10, 11, and 12. They don't specify that you have to use that format. So I'm going to show you the way that I do it, because as far as I'm concerned, I think my way is easier. So I show not as a line like that. So that for me would be not A or B. Okay, so we've got not A or B is equal to A and B, like that. So that's De Morgan's first law, and essentially we learned it when I was back at school as break the line, change the sign. So you can see there, if we broke the line there, we had to change the sign. Okay, so the plus changed to a dot, and then we put we had broken the line. And then if we look at his other law, which is like, I'll just put it next to here. So if I've got A and B is equal to A, now I'm going to break the line, so I've got to change the sign. Not A or not B. So there we go. So De Morgan basically allows us to change from OR gates to AND gates in your circuit, or it just allows you to simplify. So let me just make that a bit clearer. Okay, so what I want to do is let's go through an example here. So I'm going to pick example 7 in the book on page 83, because I think they leave out a step there, which doesn't really show you how they've done it. Okay, so what they say is they give you this function. They say a function of x, y, and z which is equal to x or not y and z. So I'm going to write that down there. I'm not going to write the function x, y, z. We know how to do that, but I'm just going to write this part here. So they give us this. They say x or, and then they say not y and z. Okay, so that's the function they give us. Now what they're asking us to do is they are saying use De Morgan's law to negate that. So they want us to negate that, okay, with De Morgan's law. So I'm going to negate it by just saying that. Okay, you could have put brackets around it and used the single inverted commas, single apostrophe like they've got. Or you can use my method, it doesn't really matter. Okay, so I'm going to negate this. So let's say that is equal to what? Right, so the rule is break the line, change the sign. So I'm going to end up with x, the plus changes. And I've got not y, z. Okay, so now I've broken the line and I changed the sign. So I've got that. So what's that equal to? Well, I've got not x. Can't do much with that. Okay, I can't do much with this, but I can simplify this. This right-hand term here, I can simplify this again with De Morgan. Okay, so I'm going to put a bracket here just so you can see what I'm doing. So I'm going to break the line. So I'm going to end up with y plus, y or z. Okay, but now I've got that and that. Is everybody following me so far?
I'm starting to get it.
Yes, sir. Yeah.
Yes, sir.
Okay, so the rule is if you break the line, you change the sign. So you could see here, okay, so I'll just go back here again. We negated the whole thing. Okay, so I look up and I can see, oh, I can break that line, so I must change that sign. So I've got the left-hand side is going to be not x, and then the right-hand side is going to be not what I've already got. And then I change the sign, okay, to an and. Okay, I can't do much with that because not x is just not x, okay? But I can see here that I can break that line again there and break it into two pieces. So I put brackets there. So I've got y bar or not y. Now I've got not y plus not z. So I can simplify this a bit further again. I've got not x, can't do anything with that. Now, not y is obviously just y because two knots cancel each other out. Okay, plus not z. So there we go. That is the answer. I could, if I wanted to, because I've sent it, so we could leave it in this format here, or okay, I could do this because we know that. Well, I mentioned to you on the last live stream that Boolean algebra, just like normal algebra, also obeys the associative law and the distributive law and the commutative law. So if I wanted to, I could rewrite this as x bar and y, or I'm just multiplying out the brackets here, or x bar and z bar. I could do that if I wanted to. Okay, so then all I've done is I've expanded out the brackets here. I'm sure you've done that a million times in mathematics up to now. So you could have left your answer in this format here, which would have been fine, or you could have simplified it down to this. It really makes no difference, whichever way you go. So that is example 7. Are we happy with that one?
Yes, sir.
Yes, sir.
Yes, I'm good.
Okay. So let's tackle example 8. Okay, so example 8, similar sort of thing. Okay, this time they've given us a 4-variable equation. It doesn't really matter how many variables they give us. Okay, we're super bright. We know how to do it all. Okay, so this time they've given us a A, B, or C, D. So that's what they've given us, and they're asking us to use De Morgan's law to negate that. Okay, so let's negate it. We're going to do that. Okay, I'm just going to draw a line across here just to show you that's a separate problem that we're doing here. Okay, so the rule is break the line, change the sign. So we're going to end up with A and B, or CD, like that. Right, so that's the first part. We'd use De Morgan to do the whole thing. Now what we can do is we can use De Morgan again on each piece of it. Okay, so you can think of it as having a bracket around there and a bracket around there. So let's use De Morgan on this left-hand piece. Okay, break the line, change the sign. So I've got A or B, and C or D, same thing. Okay, I broke the line, changed the sign. There you go, problem done. Okay, it's about as simple as you can get it in that format. So example 8 was actually even easier than example 7. We just keep using De Morgan until we can't use it anymore. Everybody happy with that?
So it's basically
Yes,
like
sir.
simplifying until you can't simplify it anymore.
There you go. That's exactly what it is. We are just simplifying it down until it's sort of in its most basic form. Yeah. So don't overthink it. Just remember that these are the two forms up here of what the equation looks like. Okay, so you can break a plus into a we'll just call it plus and multiply, or you're going to break an or into an and then instead of having a line across both, you're going to have a line atop each. So it's, like I said, the easiest way to remember it is just break the line, change the sign. There you go, and you just keep doing it until you can't do it anymore. Right, if everybody's happy with that, then I will just stop sharing my screen. And let me just stop the recording.